Our I can statements today are I can calculate area in customary units. The customary units we are working with are inches, the smallest unit, feet, which is 12 times as big, and yards, which are the same as 3 feet. Our next one is I can convert between feet, yards, and inches to find area. So the figures you're going to be working with today will have different units measuring each side. So you'll have to convert before you can find area. Let's look at an example. Here we have a complex figure. You'll notice that I've put right angle markers in the corners so that you can tell they're right angles, even though my drawing isn't perfect. This doesn't look like 90 degrees, but because I have put this here, we are going to consider all of these angles 90 degrees or right angles. So when I look at the figure, I need to first look at which sides are labeled and which sides aren't. If there are sides that are not labeled, I need to label them so I don't forget what they are. So I can see that this is labeled 6 feet, 8 feet. This one is not labeled, and neither is this side. So I'm going to need to find those for sure. This one is labeled, but it's labeled in yards, which does not match the other ones. These are feet. We have yards here. And over here I have 4 feet. So I'm missing these two sides. So I'm going to find those first, and then I'll be able to find the area of everything. The first thing I'm going to do is I'm going to find this easy one right here because it tells me how long it is. It's just not in the right unit. So I'm going to convert this into feet. And if I remember my conversions, 1 foot is the same as 12 inches, and 1 yard equals 3 feet. So I can just change this from 1 yard to 3 feet. So I'm going to rewrite it underneath. That is the same as 3 feet. The next thing I'm going to do is I'm going to figure out what are the missing sides. And I know that these are right angles, so this distance from here to here is 6 feet, which is going to be the same distance as from here. We'll continue this line all the way over, from here to the top up here. So that's 6 feet from here to the top. And I already know that this side is 3 feet. So if this is 3 feet, and this is vertical, whatever 3 feet is plus this has to equal the total of 6 feet. Well, 3 feet plus 3 feet is 6 feet. So I know that that is 3 feet. The same thing is going to go the other way. I know that from the left side here to the right side here is 8 feet. It tells me right here. So because these are right angles, I can go down to the bottom and say, yep, from here all the way to here is 8 feet. And I know part of that. I know this part right here is 4 feet. So the remaining part must be 4 feet as well. 4 feet plus 4 feet will equal 8 feet. So now I have all my sides labeled, and I'll be able to find the area. I've made kind of a mess of this one, so I'm going to redraw it down below. So I've redrawn it. It looks a little better. It's a little easier to follow. I can't find the area of this shape, so I'm going to need to cut it into shapes that I know. And I can cut it one of two ways. I could cut it right here and think of it as 2 different rectangles that way, or I could cut it right here and think of it as one long rectangle this way and one small one this way. I've decided to cut it vertically, and I'll find the area that way. So if I look at this rectangle right here first, I can see that the dimensions over here are 6 feet, and right here are 4 feet, and that is the entire distance. So my equation is 6 feet times 4 feet equals 24 square feet. And over here, likewise, I can see that the distance horizontally is 4 feet, and the vertical is 3 feet, so I can write the equation 4 feet, 3 feet. And I know 4 feet times 3 feet is 12 feet squared. if I think about those together, I've got 24 feet plus 12 feet squared, or 24 square feet, 12 square feet, and if I add them together, I get 36 square feet. And there's my answer. I converted, and I found the area of a complex figure.